Hey everybody, here we are, section 7.6, assessing normality. I think you'll like this section. It gives us a little bit of a break because I kind of think it's a little simpler. We'll see. Hopefully you will feel the same. So we're going to use dot plots to assess normality using dot plots or box plots or whichever one I said the last time, and histograms and stem and leaf plot and a normal quantile plot to assess normality. Now, what we're doing is we have a smaller set of data and we want to know whether it's normal or not. And sometimes that's difficult to see. And then sometimes there's easy ways that we can just take a look at it using one of these methods to see if it's normal or not. And it's important for us to know whether it's normal or not, because then we can use a lot of the things that we've learned so far that correspond to normality. So let's look at using a dot plot. So many statistical procedures require that we draw a sample from a population whose distribution is approximately normal. But we don't know if it's approximately normal when we draw the sample. So the only way we have is to examine the sample. Here are 3 things that we need to remember when we're doing all of these. We're not trying to determine whether the population is exactly normal. We're assessing normality is more important for small samples than larger samples, as we know in the larger samples how we can say that they are normal. And hard and fast rules don't work well, so you have to use some logic and examine things. We will reject the assumption that a population is approximately normal if the sample has any of the following features: if it contains an outlier, if the sample exhibits a large degree of skewedness, or if the sample has more than one distinct mode. If the sample has none of the preceding features, we'll treat the population as being approximately normal. And we often use plots to assess this normality. The accuracy of an oven thermostat is being tested. The oven is 360 degrees Fahrenheit, and the temperature when the thermostat is turned off is recorded. A sample size of 7 yields the following results. Is it reasonable to treat this as a sample from approximately normal population? Let's take a look. We're going to make a dot plot, and the dot plot does not reveal any outliers. The plot does not exhibit a large degree of skewedness, and it doesn't look like it has more than one mode. So we can treat this sample as approximately normal. A recent health fair, so hundreds of people had their pulse rates measured. A simple random sample of 6 records was drawn. The pulse rates beat per minute were as follows. Is it reasonable for this to be considered normal population? Well, we're going to use the dot plot, and we can see that on the dot plot, 98 is an outlier, so we should not treat this sample as a normal approximation. This person might have ran across the fair to get their pulse rate checked, so they wouldn't be considered in with the other data. How about using a box plot? So if we have this and we create a box plot like we've learned how to before, we want to take a look at it and reveal whether or not it has outliers and whether or not it is skewed. And how we can do that is we're going to look at the interquartile range here, and we see that it is here. We have a whisker here. We have a little bit longer whisker here, but it's really not anything that would be skewed. So we can treat this sample as approximately normal population. A recycler determines the amount of recycled newspaper in cubic feet collected each week. The following are results for a sample of 18 weeks. Is it reasonable to treat this as a sample from approximately a normal population? All right, let's take a look. Here we have the box plot, and notice in this box plot it is heavy to the side, and we have a long whisker here, but we also have this outlier on the end. As soon as we see this outlier, we can say that it would not be treated as approximately normal. And frankly, when you get the data and you're taking a look at this, you might be able to kind of look at that and say, well, this one looks like it could possibly be not treated as normal because that looks like an outlier. But the box plot does verify that for us. Using histograms to assess normality. Diameters were measured in millimeters for a simple random sample of 20 grade A eggs from a certain farm. The results were, is it reasonable to treat the sample as an approximately normal population? So let's take a look at this histogram, and we look at it, we see that it really only has one peak. It doesn't reveal any outliers, doesn't have a large degree of skewness, and there's no evidence that it has more than one mode, so we can treat this as a normal population. The shoe manufacturer is testing a new type of leather sole. The simple random sample of 22 people wore the shoes with the new sole for a period of 4 months. The amount of wear on the right shoe is measured for each person. The results in thousandths of an inch were, and is it reasonable to treat the sample as approximately normal? Let's take a look. Okay, so here we can see that we definitely have skewed to the right. So we should not treat the sample as a normal population. How about using stem and leaf plots? Here we have a psychologist measuring the time it takes for 20 rats to run through a maze. The time in seconds are these. So construct a stem and leaf plot for each of the data. Is it reasonable to treat this as a random sample or approximately normal? Now, the nice thing I like about stem and leaf plots when we set them up, if we would turn them around, I think I can maybe just rotate this and show you. Oh, no, I think I had it right the first time, huh? Let's go back to that. There we go. So you can see here that it looks like a histogram, and you can turn it sideways and, you know, kind of get an idea. So there's no outliers. I'm going to make you dizzy again, turning it back around. There's no outliers, no strong skewedness or multimodality, so we can treat this as approximately normal. Now, the quantile plots to assess normality, I will say, they seem like they take a lot more work. But if you have your calculator and you can do it, then I think that's a different story. But normal quantile plots are a little more complex. The following example illustrates how to construct a normal quantile plot. We have a simple random sample, size n is 5. We want to determine whether it's approximately normal. Here's the 5 samples in increasing order. All right, we're going to let n be the number of values in the data set, and n values are evenly over the interval from 0 to 1. Well, how do we do that? Because they're obviously not 0 to 1. So how you do that is you use this formula here to assign the values. So you're going to take 2 times n minus 1 divided by 2n. So if we take a look at the first one, that would be 1 over 2n. And the second one, 3 over 2n. And once you do all of that by using n equals 5, the values will then become right here in the chart. Okay? Now we're not done there. After we do that, we want to find the z-scores to determine each of these areas. So we have to use this and find the z-scores. After we find the z-scores, then we set these up as coordinates, with x being the original data, y being the z-score, and here we have a scatter plot. Now, if I take a look from the straight line, if the points deviate from the straight line, it should not be treated as normal. However, this one do approximately flow with a straight line, so we may treat it as approximately normal. Now, I know we haven't done scatter plots yet. We will in another week, I believe. So if this is a little bit confusing to you, just, rewind, go over the video again. I'm sure you guys will get it. So we can use a calculator for normal quantile. We're going to enter the data into our list, press second Y equal, and access the stats plot menu, and select plot 1 by pressing 1. Select on, and for the data list, select L1. For data axes, choose the X option. Data list, axes. Hit zoom, and then zoom stat, and then you will have your scatter plot. Pretty nice. Still a lot more work than the others, I think. All right. So we have a placement exam given each of the freshmen at a large university. A simple random sample of 20 exam scores is drawn with the following results. Right away, I'm looking at this over here going, let's see. Let's construct a normal quantile plot using technology. Is the distribution of the exams approximately normal? We're going to take a look. We see the points on a quantile plot do not follow a straight line. You see this curve up here? So this distribution would not be approximately normal. All right, so that's it for section 7.6. The conditions for rejecting the assumption that a population is approximately normal. How to use a dot plot to assess normality. How to use box plots to assess normality. How to use a histogram to assess normality. How to use a stem and leaf plot to assess normality. And finally, how to use a quantile plot to assess normality. All right, well, next section will be Chapter 8, and I will see you soon.